10. And we will do the exercises on Bayes' rule application. So here in this exercise, I'm going to first give you a sample exercise, how it is solved, and then I will give you to try some of the exercises similar to this one. And we will see what kind of rules we will apply in these exercises. So here we have the simple classical email spam detection filter, and we will use the naive Bayes spam filter. So here, assume that you receive an email with the following words: congratulations, you've won free prize, click here now. And you want to use the naive Bayes, okay, to check whether this email is likely spam or not spam. So usually in order to solve this type of problems, we need to have some prior knowledge. في الفورمال لوجيك سميها knowledge base، وهنا نسميهم probability هم priors or conditional probabilities. And so the probability of having spam 40%, 60%. How did we get these values? Let's assume that we make like statistical analysis on all the emails that we can receive. And here we have the word likelihood table, which gives, these are some things that we can get. Imagine that you have a lot of emails. We know what is spam, what is not spam. And in all the spams, we found that this word exists 80%, 70%, 65%. So these are condition probabilities given the probability of the word given the email is a spam, and the probability of the same word given the email is not a spam. And now the question is to determine if the email is a spam. So now the first thing that you need to know, and you put in your mind, what do you need to calculate? So imagine just give you this question. What do you need to calculate? What is the probability? Huh?
The email being spam?
The email being spam. So it's the probability of spam?
Based on
the 3 keywords.
Yes. So probability of spam given that we have observed these keywords. So now we talk about we have an evidence. What is our evidence?
free web click.
Okay, so usually in Bayes we want to calculate a posterior given an evidence. So we need first of all to identify what is the evidence, what is the posterior. What is the evidence? The words observed. What is the posterior?
Spam or
Spam. So what is the probability of a spam? The posterior. The posterior is something that I don't know. And the evidence is something that I know, that I have observed. So I want to calculate what is the probability of this email being spam, which I don't know, given that I know that this email contains the following evidence, the 3 words. And now we have sufficient information to be able to make this derivation. So this is what I'm going to jump here. This is what we want to calculate. This formula. Probability of spam given words. And we apply the Bayes rule. The Bayes rule, probability of A given B is the probability of B given A multiplied by the probability of A divided by the probability of B. Is the probability of the evidence given the posterior, the likelihood, which we call the likelihood, multiplied by the probability of the spam divided by the probability of the evidence. Word is the evidence. And we're going to find the formula like this. So what do we have now as information? And what we don't have among all the data? What did he provide you?
Oh, you have everything except spam and given words.
I have this probability of spam.
Yeah.
Do we have this?
Yes.
No, I don't.
Why?
It's not given. This is what I give you. Spam, not spam. And you have this conditional. But this conditional is not the word, it's the word given, something. Okay, so now, in order to calculate this, I need to calculate the 2 unknown. This one and this one. Okay, we need to identify what are the unknowns. طبعا these unknowns, we can determine them from the data that is given to us. And I want you to have this systematic way of thinking on how to decompose a problem and then solve it. Okay, yes? Huh? Let's see. Now this is what you have. What is the likelihood? Okay, we don't have. So here we have, this is the likelihood, but word by word. Now the likelihood of these 3 words, so what are the words that appear here? I have free, I have win, I have click. So I need to calculate the probability of having win, free and click given this email is spam. Okay. So this is the formula. Now my question, how did you get from here to here?
You said you wanted to calculate only given the spam.
Yeah.
So you put it in مجموع الحكم ثلاثة as one variable, so you can use it.
So I want to calculate this. And for this I need to calculate this. Okay, and this is exactly the following. This is what I want to calculate. Okay, the probability of the words given the spam. Now, I'm just writing this one. Why this is correct?
Because it's all the words.
You have distribution.
And conditional probability is it equal to the product of probabilities? So here we have joint given spam. How did I decompose it into why I make أنا وقتاش نعرفوها what is the probability of joint? Okay, let's شوف chain rule. الآن أنا what I did is like I made probability of A and B and C is equal PA PB multiplied by PC, but this is the chain rule. Why I didn't apply this? Why I did it in this way?
Because they are not dependent. They're independent. They're
هل الكلمات dependent ولا independent؟
completely independent.
الآن we missed something. We made an assumption. When we work with naive bias it assumes that the words are independent. واضح؟ So you need وقت اللي نقول له naive bias يعني these events الآن words, the events can be something else. They are independent. The events are independent, and this will allow you to simplify. So they are not independent in practice, in reality, but we made this assumption. So we're going to have like an approximation, and we consider they are independent. So we can just calculate this joint probability as the product of probabilities. Okay. And multiple probabilities of the word appearing in the spam is the following. And now, what is the probability of free given spam? We're going to go to our CPT, condition probability table. We have probability of free given spam is 80%. So I'm going to put 80% here. The probability of win given spam is 70%. And since it is joint probability, we're going to make the product, and this will give us this number. Does it make sense? What is the second unknown? The probability of the evidence. And we have all these three words together. So how can we get it? Probability of word. How do we calculate it? أنا شوف عنا الآن. أنا probability of word given spam and the probability of word given not spam. What is the law that we will use? No. We're going to use the law of total probability. The probability of the evidence is the evidence given the hypothesis. We have the hypothesis can be spam or not spam multiplied by the probability of the hypothesis. So this will take us to the following. Probability of free, win, click. And الآن we calculated this صح ولا لا? So we want to calculate this. Probability of words. Using the law of total probability, we can write it. Probability of words given spam multiplied by spam plus the probability of words given not spam multiplied by the probability of not spam. So we're gonna make on all the different hypotheses whether it is spam. يعني الكلمة هذه يمكن تجي في spam or not spam. So we're gonna calculate all probabilities, the sum of all probabilities. مثل ما سوينا في ال MDP, Markov decision process. شفتوا الآن this is part of MDP by the way لكن مبنية على الأصل law of total probability. Okay. Yeah, I'm gonna go to it. Now we already calculated this, right? So we already calculated this, but we didn't calculate this. So how can we calculate it? In the same way. اللي يتغير الآن أنا أخذت من الكولن هذا I'm gonna take from this column. Okay? So the probability of all these words given ham نفس الشيء, it's the product of all probabilities. That's going to give me this number. And then you can have, okay, so I have everything now. This value I calculated اللي هي 0.3 364 multiplied by 0.4. What is 0.4? From where you get this value?
Given, right?
Huh?
We know that.
Yeah, we know from here. We know from here. Multiplied by this value that we calculated, multiplied by 0.6. What is 0.6?
Given also.
It's given on the top.
Yes.
So I calculated this value now, and finally I have all the different numbers I need. So doing all this, the probability of word given spam I calculated, multiplied by probability of spam 0.4, divided by the probability of evidence, which I calculated here, is going to be this number. So here the final classification, knife bias says 99%, this is spam, makes sense. So now you understand, but it's time to practice. I'm going to give you 10 minutes to solve this problem, which is very similar. But don't look at the solution. Let's solve it, and let's identify where we will make mistakes, and then we can improve. So look now, we have an email, another email, meeting tomorrow at 3 p.m. Please confirm. And here we have two words that they can infer whether spam or not. So we give you the CPTs here, and we give you the prior probabilities here. So try to follow the same steps that you did before, and give me the number that you will find. Yes, yes. الآن لازمكم تفتحوا اشتغلوا groups and try to solve it step by step. Okay, so now, okay, let's try to solve this together. Okay. اليوم I need to focus on this. And هذا ينبني عليه كل شيء. But I can solve this with you, inshallah, no problem. حتى كان أعمله online, no problem. So now the objective is to calculate what? This one. Okay, so this is how we reason about the problem. Okay, which is the probability of spam given that we have observed the words. Okay, so now spam is the posterior, and I want you to understand these words. Posteriors, but what does it mean posteriors? Is what? Okay, let's say hidden event that we want to calculate its probability given the evidence. Okay, now we have also the words. In our case, they are meeting and confirm. Okay, these are the words observed, and we call them the evidence. Okay, so actually we want to calculate the probability of the hypothesis, the posterior. We call it sometimes hypothesis. It's hypothesis, افتراض. Given that we observed an evidence, according to the Bayes rule, equal to what? The probability of evidence given hypothesis multiplied by the probability of the evidence divided by hypothesis divided by the probability of the evidence. Now we know what is our evidence. So this is hypothesis, okay, and this is our evidence. So from the questions here, we have the probability of P spam. P spam, okay, is given. So now applying this, I'm going to make P of spam given words is equal to the probability of words given spam multiplied by the probability of spam divided by the probability of the evidence, which is the probability of words. So from the context above, we are provided, yes, we are provided what? We are provided the value of P spam. This is what is given to us, صح ولا لا? Which is equal to 0.35. Yet we need to calculate what? P of words, which is not given, and P of words given spam. Okay, let's start with this one. Probability of words given spam is equal to what? Now, I have this table which gives me the probability of word given spam and the probability of word given ham, but I don't have the probability of we do have probability of word given spam. So what are our words here? Meeting and confirm. So this will become probability of the meeting given spam. Now, going to the conditional probability table, we can derive probability of meeting. What is the probability of meeting given spam? Equal 0.15, this value. And I'm decoding the problem, okay? I'm making the solution fully decoded. And then we have confirm given spam, which is 0.25. Now, if I want to calculate this, okay, is equal to the product. What is the reason of writing this? Because we use the naive bias, okay, which assumes that words or events are independent. Otherwise, we need to use the chain rule, all of it. So, and this give what? 0.25 multiplied by 0.15, which is equal to 0.3. 0375. Okay, so this is the first part. And then what is remaining? Now we need to calculate probability of words اللي هما equal. So now from this table I have probability of words given spam and probability of words given ham. So using the rule of total probability, which is this one. Okay, this is the rule. So we need to know the rule and we need to know how to use the rule to solve the problem. And this will make it probability of words given spam multiplied by the probability of spam. And if you remember MDP, we have used this, okay, to make the calculations in MDP. And plus the probability of word giving its ham, and here the same thing. And what will be the value? So we have calculated this now. Okay. Okay. And we calculated this value, which is equal 0.035, which is this one, multiplied by what is probability of spam? 0.5, huh? 35 plus. So we need to calculate the same thing. We're going to use the naive Bayes rule, which assumes that they are dependent. So it's like the probability of, it's the product of 0.6 multiplied by 0.5 multiplied by the probability of ham, which is 0.65. Now, what is the number you find? 0.208125, I think, right? So now we have everything to calculate this. I'm going to come back to this formula. Okay? And, you know, I will just bring the values. This value multiplied by 0.4 divided by, this is 8, divided by this, and this is going to give you 0.0630, which is like 6.3% as probability of being spam, given that the email contains these words اللي هما meeting and confirm.
In the probabilities, 0.35, not 0.1.
0 point?
Yeah.
Where, here?
No,
On the right.
تضرب في 0.4.
What is this? 3.5. Okay. Okay, and we apply the same thing for any problem. Now I think you can solve this problem as well, the one afterwards.
Yeah, it's the same way. Yeah.
Same way. Okay. Now if you want just to jump into the solution. Okay. Yeah, اشتغلت الحين. So this is how it works. So in the same way here we have different values: offer, discount, product, given, spam. It's basically the same thing. We calculate these probabilities and probability of words, and finally we apply the Bayes rule.
This is mutually exclusive from everyone.
Hmm?
This is mutually exclusive
Yes,
for everyone. That's
because
why-
we consider independence. Because we consider the independence. Okay, and same thing. Now let's look at another type of questions. It's basically naive bias. Sometimes we can give you some information different from what we have given to you. Now, in the previous exercise, we have given to you the prior and conditional probabilities. But here, in this exercise, let's read it first. So we have patient in Riyadh takes a COVID-19 rapid test. And the test was positive. What is the actual probability that they have COVID-19? And use the Bayes theorem to find it. Now, what is the first question we need to ask? What is the posterior? What is the evidence? So, what is our evidence? We have a positive test. We have observed that. So, this we consider the evidence. What is our posterior? Is it COVID or not COVID? Okay, so what are we going to calculate?
COVID given positive.
ممتاز. هذا أهم شيء. You need to identify the right question. What do we need to calculate? Is the probability of COVID given the evidence is a positive test. So always you need to identify the posterior. If you don't identify what is the posterior, what is the evidence, you cannot solve it. That is the first thing. Now the second thing, I need to know what is given to me to solve this problem. So at the end, we're going to use the same Bayes rule, which is this one. Probability of COVID giving positive test is the probability of positive test given COVID multiplied by probability of COVID divided by the probability of positive test. What is the evidence? Okay, this is the evidence. And this is which rule is this one? The Bayes rule. كله مبني على البايز.
Can you show the positive?
Yeah, we will see. We will show. So for doing that, this is what is given to me. I have the probability of COVID, which is the prior. Okay, I have the prior. But here, I have the likelihood. The likelihood is provided. Before, in the previous one, we had to calculate the likelihood. Now, the likelihood is provided because this is the probability of the evidence given the hypothesis. So it's given 0.95. And here, we give also the other likelihood of non-COVID. Okay, incorrectly show. This is like false positive. Probability of positive given it's not COVID. Some people are not COVID and they get the test positive. You know, this is a sensor. And this sensor can have errors. So, what is missing now?
Probability of COVID given positive.
So now we have the prior and we have the likelihood because it's the probability of positive given COVID multiplied by the probability of COVID. We do have these two information. We divide by what? Probability of positive. We don't have it. How do we calculate it?
0.95.
How do we calculate this? Yeah, we want to calculate this evidence. So we're going to use the probability of the law of total probability. Okay, the probability of positive is equal positive given COVID, which is given, multiplied by the probability of COVID, which is given, plus the probability of plus given non-COVID, which is given, multiplied by the probability of non-COVID, which is 1 minus probability of COVID. Okay, I didn't give this explicitly, but this is inferred from here.
How do you infer this one? You do 1 minus this one?
What is the probability of the not event? If you have PE, what is the probability of not E? is 1 minus the probability of E. So the probability of not COVID is 1 minus the probability of COVID. And this gives the following calculations. We have all the values now. صح ولا لا? And this will give the probability of having a positive test regardless is 0.0673. And then we have everything to calculate the Bayes rule. Yes.
So does this give the accuracy of the sensitivity?
No, this gives the probability of the evidence. Yani the probability of this evidence is equal to 6%.
Like the probability that the person has COVID given test is positive, isn't this accuracy of the test?
Which one? This one?
Yes.
Yeah, this is the accuracy of the test. And this is how the false positive of the test. This is sensitivity, we call it sensitivity. Okay, and this one,
Why doesn't this equal to the probability that the patient tested positive, given that this is sensitive? I don't get this point.
formulate your question so I can understand your question.
So if it's 95% accurate,
It's not accurate. This is not accuracy.
so we're calculating accuracy.
Yeah, the sensitivity, I think in machine learning, you're having machine learning model. What's the difference between accuracy, precision, sensitivity, and recall? False positive or false negative, a combination of all of them. Okay, الآن this is the probability of the having a positive test given that the guy is having COVID. Okay, it's not absolute. It's conditioned on معناها الآن there are many people who are having COVID. 95% التست يعطيني positive and 4% the test is going to be negative although the guy is affected with COVID. But this is what we call false positive rate. False positive. Okay.
It should be 5%, right?
Huh?
It should be 5% to complete the one.
They should, not necessarily they sum up to. Okay, what sum up? Okay, this is 4%.
Yeah, but this is also he's talking about not having COVID, getting a positive.
Yeah, false positive.
Yeah,
He
false positive.
doesn't have COVID, but he gets a positive result.
Yes, yes.
It's a different.
Yes, it's different. لأنه عندك 4 combinations. Plus given COVID, negative given COVID, plus given not COVID. Yes, we have 4 combinations. Okay. So now, given this, we need to calculate the probability of the evidence. And we have 2 situations. This evidence can be positive if the guy has COVID or doesn't have COVID, considering the correct cases and the incorrect cases. So we're going to sum over all these possible hypotheses. واضح? And this is give me the probability of the evidence. طبعا, this is just the law of total probability that we have already introduced here. Does it make sense?
So you skipped 3 steps from the original because all of the
No, well, I didn't skip any steps. The other one is giving you some numbers, and this one is giving different numbers.
Yeah, because he's not-
So here, the likelihood is given. In the previous case, we had to calculate the likelihood. But now the likelihood is given. So we gave different type of information. So there is no memorization. You need to understand the problem. You need to understand what is provided to you and what you have to calculate. It's always like this. Okay. So these are 2 possible cases of what we can give as yani assumptions. And based on this, you need to calculate. Now, try to apply on this scenario. 40-year-old patient undergoes screening. So just give me the value that you will find. I think now you can calculate it even
it's
very.
Is it 0.8 multiplied by 9 plus 0.7?
No, yeah, no. Take your time. Make your calculation.
0.08 is
0 point. Let me check the value.
probability of a positive multiplied
9.4.
probability of positive.
Just a moment.
That's what
You have something.
negative total.
It's 9.4%.
I don't understand the sentence.
Okay, let's see. We're going to apply the same thing. Look, let's decode the problem again. So what do we need to have? What is our evidence? The evidence is positive. What is our posterior? Cancer. So we need to calculate P of cancer given a positive test. So what is given to us? Cancer prevalence at this age, 0.8%. This is what? This is the prior. Okay? Test sensitivity, 90%. What is this? The likelihood. Okay? False positive rate, 7%. So now we have the same as the previous example. So what is missing now? I want to calculate probability of cancer given positive test is equal to the probability of cancer, probability of positive test given cancer multiplied by probability of cancer divided by the evidence, probability of the evidence. Now I have both of them. I have this and I have this. Here's the likelihood. So what is missing now? Same thing. It's missing the probability of positive test. Okay? And we're going to apply the same formula. I have all these values. Okay? So you have 0.9, which is your likelihood multiplied by your prior.
There's a mistake
Hmm?
in the 0.8.
Yes.
P0.008, yes.
But it says 80%.
No, it's
Ah.
0.8%. Okay. Yeah. So pay attention to the numbers. Okay, you need to add 2 zeros. Okay? And plus 0.07 multiplied by 1 minus 0.008. And this gives this value. Okay, so don't make mistakes in the calculation. Sometimes you know the formula, but numerical calculations could get you wrong. Clear? Okay. Try to find me the number here. 2 minutes. And you need to work on the speed, not only on correctness. So to save time. Huh? So what is this value? Who is the fastest? من غير ما يشوفها. Without seeing the result. Okay, give me the first value and the second value. The first value is the probability of the evidence. Huh?
85% is the evidence.
No, the evidence, probability of positive. How much?
The answer is 0.43, which is 43%. Right, so
0.234.
no, that's the first step. Second step.
The first step. I'm talking about the first step.
Ah, yeah.
What is the first step?
You take the probability of.
The value. Give me the value. هنعرف how many correct values. Give me the value for the first step and the second step.
It's 0.234.
Okay, and the second one?
Second one, 0.435.
0.436. Okay.
5% is the wrong.
واضح ولا لا?
Yeah.
Are you able to calculate? Yes. You know, my advice is do that 10 times. 10 times the calculation. خلاص until you don't need to think when doing these calculations. Okay. Repeat them until you don't make mistakes. Okay, and try to do the following one and identify in which category is this. I'm not gonna solve it, but try. Give me the numbers. ما غير ما تشوفوا solutions. Give me. Okay, before solving this, let's first identify how to formulate the question. Now we have the weather service observed dark clouds forming over Riyadh this afternoon, like it's today. Using historical data and Bayesian inference, calculate the probability of rain tomorrow.
But it's not that is given.
Yeah, so let's assume that we have historical data that is collected. يعني على مدار السنة 15% it can rain over Riyadh and 85% of the day it doesn't rain. And from meteorological records, we got the information of the probability of having cloud given it will be given we observe rain is 80%, and the probability of having dark clouds with no rain is 20%. And sometimes you can have clouds, but you don't have rain. Okay. So, what is our evidence?
Evidence is the likelihood. Is the
What is the evidence here? Huh? Dark cloud. What is the posterior? Rain tomorrow. So what we will calculate? The probability of rain, given that today we have cloud. واضح? This has to be clear in mind. Then we go to the computation. Now since I want to calculate probability of rain given cloud is equal to the probability of cloud given rain, which I have, multiplied by the probability of rain, which I have, divided by the probability of the evidence, which I don't have, which is the probability of clouds. Now given this, I can calculate the probability of cloud. What is the probability of cloud?
See,
Give,
no.
yeah, give me the number. Just make the computation, give me the number.
Just 0.8.
Okay. Give me the number now.
0.16.
Huh?
41%.
41%. كل حاجة تعطينا number.
0.16.
No, I must calculate it, you know. You use the law of total probability.
Yeah, 0.8 times 0.2.
0.8.
Times 0.2.
لا ما خطأ. The law of total probability. 0.8 multiplied by 0.15 plus
No, that's
0.20 multiplied by 0.85.
Yeah, 0.29. 0.29. Yeah, yeah.
ما تخطئوش بعض الأحيان مش يعملوا it's not joint probability.
Doctor, yeah, what's okay? Joint probability is.
It's
when-
not. This is the law of total probability. You know this one.
When do we use the joint?
This one.
The joint.
No, you know, now you calculate, look, probability of, and you have an evidence with multiple conditions. We're going to sum up of all these conditions. معناها you can have the cloud with rain or without rain. وكل حد باحتمال. Okay? So it's the condition probability that the cloud given rain مضروب في احتمال الرين plus the other one. You have a union of two events. A union of intersections. If we think about it. Okay? So this is how it's calculated. Probability of cloud. This is the law of total probability. Okay, so please do this computation multiple times until you don't have any doubts. And do them manually by hand.
Yeah, then
Okay.
we use the clouds.
We have the P cloud, خلاص. This is the missing part in the Bayesian. All we did now it's just the application of the Bayesian rule. Inshallah, now I'm going to send you the final exam. Of course, it's a mixture of, as I already told you, and from the project, from game theory. And you know, Bayesian is going to be like the largest part of that.